All right, so in this video, we're going to continue where we left off. So just to kind of review what the model was. So if we have daily log returns, we're trying to simulate a stock price for tomorrow. So it hasn't happened yet. That would be equal to its daily mean plus the daily volatility multiplied by z of t plus 1. And this is the z is what we're going to simulate. So z is going to follow a standard normal distribution. And remember, if we're trying to simulate stock prices, we need to simulate the return if this is the model of return, but we need to get back to the actual stock price. Remember that the stock price, or the return, the log return, will be equal to the natural log of the stock price tomorrow. So the log return of tomorrow would be equal to the closing stock price of tomorrow divided by the closing stock price today. So this is what we're trying to simulate. And back from the other video, we get the formula. The closing stock price tomorrow would be equal to the closing stock price today multiplied by E to the power of the daily return plus the daily volatility multiplied by a Z of T plus 1. And this would also be equal to stock price of today multiplied by E, or E to the power of the daily return multiplied by E to the power of the daily volatility, ZT plus 1. But that doesn't really, that's just algebra. It doesn't really matter for this. Either formula would work. They both give you the same thing. So this is what we're going to do in Excel. We're going to start out with simulating about 5 paths. I'll show you what it'll look like. So we're going to simulate our paths, and then it will open up, and you can really see the shape of the distribution. We're not going to get too detailed in this on the video, but if you go to the PDF and you want to learn more, it is there. So now I'll switch to the notebook file. And we will now actually simulate it. So I'm going to import NumPy, Pandas, SciPy, and so on. And let's get our stock prices from Stook. So let's do stock prices. Let's do stock prices is equal to our data reader WB data reader. Or name. Let's do IBM to be consistent with the PDF file. Let's do the data source. So we don't need an API key. Let's do Stook. And we just want the closing stock price. After you do this, what happened here? After you get the stock prices, remember that whenever you get it from Stook, typically the index will be sorted in descending order. You don't want that. You want it to be in the earliest state to the latest state, not vice versa. So we need to sort the index just to make sure. So sort index and make sure it's in ascending order. So ascending equal true. You want to keep it in place. So in place equal true. Then let's go ahead and create our stock returns. So stock returns is going to be equal to, there's 2 ways to do it. You could do in NumPy you could be numpy.log stock prices minus numpy.log stock prices shift 1, or you could do the numpy log of stock prices percent change plus 1. Either one will work. They give you exactly the same output, and we went over that in a previous lecture. I think that was before the break, before all this happened. So if we do dot describe, we can see the statistics. So we have the mean, the daily standard deviation. If you look at the notes, this goes up to the most recent. So if you look at the notes, you'll see different numbers. It's because it was a different date. As was in the notes on the PDF, it was back in early February. So now, of course, things have changed a little bit. Anyway, let's plot stock prices. Let's do a dot plot. We'll look at it. We can see the stock prices, or the closing stock prices of IBM. You can see that there was a pretty big drop, so that brought that mean down. So if you look at the PDF compared to this, it is different by, I think, of a factor 3 or factor 4. So it's not small. Anyway, so the mean is a lot smaller than there. I think the volatility is also higher on here than what it was on the PDF. But again, that's just because of what's recently happened. It's because of that big drop there. So anyway, this is our stock prices. Now let's look at our stock returns just to see what that looks like. And you get looks like an increase in volatility. You see a big drop. So that's of course not good, but you can see it there. And then so now this isn't what we're trying to do. We're trying to simulate it. So now let's actually simulate our paths. So let's do 30 days into the future. So number of days out be the 30. Let's do a number of paths. Let's do 5 paths starting out. And now let's do the now let's actually simulate the prices. To do this, the easiest way may be to just create a matrix of 1. So the shape is going to be the number of days. So the number of days is going to be the row. So it's going to be 30 rows long. And then in the columns, we're going to have the number of paths. So we're going to have 5 columns. We're going to initialize a blank matrix. We also want, because remember, it's based on the recent prices. Let's do 31 instead of 30. So this will actually be 30 days because we need the first day, the first period in this, the first period, so the first day, to be equal to the most recent stock price. We're trying to simulate stock prices. So if we run this and look at it, we look at sim prices, we're going to see this. So the most recent stock price was 106.34, and the rest is just ones. We're going to fill up the ones based on this this value. You could do this a few different ways. You could append it. You could just fill in the blank like what we're going to do. You do it a few different ways. This is just how I chose to do it, to try to show the steps that we're doing. There's more efficient code to do it than how we're doing it here. But again, I just want to make sure you understand all the steps that we're doing. So for the model, for our model, I'll go back to the whiteboard. Our model is this. We need to the most recent stock price, so the previous day, multiplied by e to the power of all of this. So we need the mean, and we need the standard deviation, or the volatility. So let's get that. Let's say my mean is going to be equal to stock returns dot mean. Let's say my volatility, my standard deviation, whatever you want to name it, is going to be equal to stock returns dot our dot std. So for standard deviation, so this would give us our volatility, our daily volatility. So now we can actually simulate the stock prices. So let's say for J, so the jth column, range 0 to number of paths. So we're going to do one path at a time. So we're going to do one path at a time. Now let's say for I in range, let's say 1, because we can't do 0. The first stock price is already there. That's historical. It's already happened. We can't simulate that. We need it to simulate the future based on the model. So let's do up to the number of days, because it goes up to, but not including that. So we'll get 30 days in this. Now we can actually fill in those values. So it's going to be the ith row in the jth column. Let's say, remember, it's the previous day stock price. So I is the day, J is the path. So we want yesterday's stock price on this current path, J. This is going to be multiplied by E to the power of my mean plus my standard deviation. All of this is predetermined. It's deterministic. We've already calculated it. But what's random, the stochastic, the random part, which is what we're gonna simulate. We're gonna do numpy.random, and we're gonna do a standard normal random variable. The default normal is standard normal, so mean 0, 1 standard deviation. Let's run it. So we did it. Let's see what the matrix looks like. Looks good. Looks what it should look like, and let's Now let's put it in a data frame so we can do built-in matplotlib with pandas. So we'll just fill that out and we'll plot it. Let's turn the legend off. We're going to title it, let's say, simulated stock price paths. Let's plot it, and there we go. We get it. So let's make it a little bit bigger. We can see it a little bit clearer. So this is it. This is it. So let's just to kind of show you what it would look like. Let's do it one more time. I'm gonna change the style. Use. Let's do Seaborn dark grid. And let's, instead of 5, let's do 25 just to kind of see what it looks like. And just so I don't have to keep rerunning 2 things, I'm going to copy and paste this up here. Get rid of that. Now we're going to do 25 paths. You can see it a little bit clearer. Now let's do, let's change the color to something. Let's just make it blue and let's make it a little bit transparent. So now we can see it. We can see it's starting to take a shape. Let's do 500 now. Let's do 500, and let's make it a little bit more transparent. Let's make it 25%. Alpha equal 25%. Now you can see that it has its formed shape. You can see it looks relatively like a normal distribution, or looks kind of like that. Kind of has that bell shape. Let's do it 1,000 times this time. Let's do it 1,000 times, and let's see what that looks like. I'm gonna make it a little bit more transparent again. So I'm gonna make it 10%, alpha 10%. And there we go. So this is this would also be called Monte Carlo simulation. So this is we simulated stock price paths, and if you look in the PDF, I have more notes so you can put the historical stock prices on it. You can plot it with the historical stock prices, then you can just open it up in a big simulation. And in that, I also have distribution plots, so you can see that that if you look at the stock price, it would be log normal. If you look at the stock returns, it's going to be normal. So stock returns is going to follow a normal distribution. Stock price is going to follow a log normal distribution. So that is something that on your second exam, depending on what kind of data I give you, that's something I could be looking for. I could give you some distributions and ask you what it would be. Anything with prices is typically log normal because the price can't be negative. So anyway, this finishes up 4.5 simulation. So we simulated dice through in a game of craps, and we simulated a stock prices, IBM's closing stock prices. So this is it for 4.5. In the next video, we'll start statistics and regression analysis.